Hello everyone, I am Varshini H, third year chemical engineering, and I will be solving a few numericals based on reversible, irreversible, and polytropic processes. First, let us define reversible process. A reversible process is one that can be reversed by infinitesimal changes in a thermodynamic variable, leaving no net change in the system and surroundings. Let us consider this problem. A mass of 0.05 kg of a fluid is heated at a constant pressure of 2 bar until the volume occupied is 0.0658 meter cube. Calculate the heat supplied and the work done. When the fluid is steam, initially dry saturated. When the fluid is air, initially at 130 degrees Celsius. Solution. Initially the system is saturated at 2 bar. So we have H1, that is enthalpy, as 2707 kilojoules per kg, and H2 as 3702 kilojoules per kg. The specific volume V2 is found to be 1.316 meter cube per kg. The heat supplied is calculated to be 18.25 kilojoules. Therefore, the work done is negative 86,080 Newton meter per kg. Therefore, the total work done by the total mass is 4,304 Newton meter, that is 4.304 kilojoules. Solving for the second sub-question, from the gas law, we have T2 equals P2V2 by Mr, which is found to be 917 Kelvin. For a perfect gas undergoing a constant pressure, we have the following formula, where Q stands for heat supplied. We get heat supplied as 25.83 kilojoules. Temperature T1 is 403 Kelvin. Work done is calculated as minus R of T2 minus T1, which gives us 7.38 kilojoules. Therefore, the process is concluded to be reversible constant pressure process. Let us define irreversible processes now. An irreversible process is one that cannot be reversed exactly, that is, both the system and its surroundings cannot return to its initial states by merely reversing the direction of the process. In such process, the system passes through non-equilibrium states and there is always some loss of energy due to dissipative effects. Let us consider this simple problem to understand irreversible process. An ideal gas undergoes irreversible isothermal expansion from initial volume V1 equals 2 liters, final volume V2 equals 5 liters, temperature T equals 300 Kelvin. The external pressure is constant at P equals 1 atm. The gas contains 1 mole. We have to find the work done by the gas, change in internal energy, heat absorbed by the gas, and they have also given us that we have to assume ideal gas behavior. Now solving the question, the work done for an irreversible process is given by W equals minus P of V2 minus V1, where V is volume, P is pressure. The work done found using the above equation is minus 304 joules. Now for heat absorbed, let us consider delta U equals Q plus W. Delta U is change in internal energy and therefore change in internal energy for isothermal process for ideal gas is always zero. Heat Q stands for heat and W is work done. Therefore, delta U equals 0. Q needs to be calculated and W is found to be minus 304 joules. Substituting the values, we get Q to be 304 joules. Therefore, the process is irreversible because it occurs with a finite pressure difference, so the system never remains in equilibrium with its surroundings. Now moving on to the next process, polytropic processes. Polytropic process is a quasi-static thermodynamic process that obeys the general equation PV power n equals a constant, where P is pressure and V is volume and n is the polytropic index. Considering this problem, Air undergoes a polytropic compression in a piston cylinder device. The initial state of air is pressure P1 equals 100 kilopascal, temperature T1 equals 300 Kelvin. After compression, pressure P2 is 500 kilopascal. Polytropic index is given to be 1.3. We have to find the final temperature, that is T2, and the work done per kg of air, that is W. They have given the value of R to be 287 joules. Solution. We are using the polytropic relation that says T2 by T1 equals P2 by P1 whole power n minus 1 by n. Now we are substituting the values of T1 and P2, P1 and n. After substituting, we get T2 to be 438 Kelvin. In the next step, we will find the work done in a polytropic process. The work done for a polytropic process is given by R of T2 minus T1 by 1 minus n, where we substitute the values and find work done. The work done will be 13 minus 1,32,000 joule per kg. The negative sign indicates the work done on the gas. This equation, this problem tells us that how a process can be polytropic. We can observe polytropic processes in compressors, turbines, and in engines. Thank you.